Okay. All right, let's go and start off. So, hope you had a good weekend. We left off talking about we were talking about limits, a little bit starting off on limits and how they work and whatnot. And we talked about continuity. So, I have a piecewise function here. And my question is the function continuous at x equals pi? All right, so emphasis. I thought you were going to take that PFA, Hayden. Getting the rules ready. There you go. Oh, Hayden. Megan knows you're here, which means Mrs. Lee knows you're here. You've outed yourself. Oh, yay. Cassidy decided to show up again. What do you mean? I said yay. I was excited. That is nice. It's like really nice. No. Cassidy, I think you're just not here enough to know what my sarcasm is like, so you think I was being sarcastic. But if you're here more, you would know that that was just straight from the heart. Cry about it. What is it? You guys are always yelling. It sounds like a personal problem. I feel like I've heard you guys say that like 10,000 times in my life. Sounds like a personal problem. Oh, yeah. It is what it is. Answer is always 0. All right. Let's roll through this quickly. This lesson won't take that long. So, is the function continuous? So for continuity, what that means is the left-hand limit must be the same thing that we get if we do the right-hand limit, and that should also be the same thing we get for just the value of the function. So the sides of the limit are the same, and they actually equal the value of the function. So let's start with the left-hand limit. So the limit as x approaches pi from the left, right? We denote that with that little minus sign. So as we come from the left, so piecewise functions we have to be careful. So we're thinking about x values that are less than pi, right? But they get closer and closer and closer to pi, but they're still less than pi. Okay, so that would fit here. So I should be using negative cosine of pi. So negative cosine of pi. Cosine of pi, of course, you guys all know from the unit circle, what's cosine of pi? Hayden? Uh-oh. Nothing? I'm sad. -1. So, the left-hand limit is +1. Now let's find the right-hand limit. So as we approach from the right, so larger values of pi, right? They're getting close to pi, but they're still larger than, so we want to use this piece. So remember, if we're trying to evaluate a limit, the first thing that we always try to do is just plug in the value, right, to whatever piece we need. So sine of pi +1, because that's what the equation is here. Sine of pi is 0. 0 plus 1 is 1. Okay, so I'm encouraged so far. The two sides of the limit are the same. That's great. Now we just have to check, does it actually equal the value of the function? So not a limit, just purely f of pi. Well, if I plug in pi, so I'm not talking about what if I plug in things that are to the left of pi or to the right of pi. Just if I plug in pi, then we use this, x divided by pi. So that would be pi over pi, which is also 1. So we can conclude, yes, the function is continuous at x equals pi. I really did have the P-series test backwards, didn't I? Yes, that's what I was telling you. You would have passed that PFA, but you got like 3 or 4 questions wrong that were just all, you had the rule backwards for P-series. And also, like I said, there's a lot of options on there that aren't even options. Like, telescoping series isn't even a series that's on that PFA. Like it's any of the objectives. It shows up in like the answer choices, so you should immediately be like, no, those answer choices are wrong, or the other things that we don't even have, right? That PFA is just ratio test, geometric, P-series, harmonic series. He's trying. All right. Hayden's going to take this. Everyone make your prediction right now for what Hayden gets. All right, he only needs 7 out of 10 to pass. What do you think he's going to get? 4 out of 10. 6. Oh, the big 6, huh? We'll see. Hayden is proved. Good luck. We're all counting on you. I'll keep looking back to see if you finished. I wonder if I can hear you with the lockdown on. Is that really what you want? To be able to listen to me teach math analysis while you're trying to take your PFA? If you're really that desperate, just pull up Twitch on your phone or something. That way you can learn about derivatives, because you've never heard of them before, right? Nope. Okay, so that's continuity. Whether we're doing it on the graph or on an actual function, again, it's just left limit equals right limit equals the value of the function. That's how we define something to be continuous. Okay, so this lesson is spliced from an earlier lesson that we did in the year, difference quotient. So I just like copied over a lot of the same slides that we did for difference quotient, because I know that you remember that, obviously, what difference quotient is. Okay, it is this thing here that I circled a lot of times. No, I copied the lesson to illustrate that we're using difference quotient now. I told you we would use difference quotient for actual calculus, and here we are. So this was difference quotient. I showed you here that it's essentially just a slope formula. Okay, but this is actually the difference quotient. So here's an example that we did. Right, we kind of split it up into like the 3 steps. First step, find f of x plus h. Do some simplifying. Second step, take whatever we got, subtract the original function. We get whatever. Third step, take that and divide it by h. And we ended up with, you know, whatever this thing was in this case, 6x plus 3h minus 2. And we use this to find the slope. So for example, I would say like, okay, now let's find the slope between x equals 1 and x equals 7. Because what the difference quotient is an ability, it's like an equation to find what the slope is. Okay, so we're going to use difference quotient now for something called a derivative. Okay, so a derivative is a limit as h approaches 0 of the difference quotient. So this what I have circled in purple is the same exact formula of the difference quotient, right? It is the difference quotient. F of x plus h minus f of x divided by h. My mentor is texting me during class. She's such a bad influence. Agreed. And then for derivative, we take the difference quotient and we say, okay, we'll take the limit as h approaches 0. Oops. Okay, so a couple key questions. What does h represent? What is h? If we look back at our problem here, like we had, okay, find the slope between x equals 1 and x equals 7, so we figured out h is 6. Well, h just represents the space between the 2 points, right? From 1 to 7, that's a distance of 6, so that's what h is, right? The distance between the two x values. So what we're saying is if h is going to 0, so we have these 2 points, but if h is going to 0, so what that means is the distance between them is becoming 0. So the 2 points are getting closer and closer and closer and closer together and closer together and closer together. And as h approaches 0, so they're getting, those 2 points are getting infinitely close to one another. Okay, so I have a little visual here I'm going to use. hopefully this is a good demonstration. We'll see. Wrong playlist. Let's see. Okay. So forget about all what the equations are, but the point is I have some curve, this green curve. Okay, and so these 2 points, right, what the difference quotient does is the difference quotient tells me what is the slope of this black line here. Right, so if the distance is from h, or from 2 to 3.2 between the x values, then this is the slope of the line, right? Or depending on how far apart I want the points to be, it could be various things, right? But difference quotient tells me what is the slope of this black line, depending on how far apart the 2 points are. Okay, but if the 2 points are getting super, super close to one another, infinitely close to one another, this is no longer, so if you remember when we talked about this, we called this a secant line, right? The secant line because it goes through at least 2 points on the graph. But as these 2 points get infinitely close together, this no longer becomes a secant line, it becomes what is called a tangent line, right? A tangent line is just a line that skims just and hits across 1 point. So as those 2 points get infinitely close to one another, there's no longer 2 points. I just think of it as 1 point. Okay, slope of the tangent line. So these 2 things mean exactly the same thing. If the question asks you what is the slope of the tangent line, it's just asking what is the derivative. Okay, I think on the PFA a lot the questions are worded. It doesn't say what is the derivative, it says what is the slope of the tangent line. Okay, so these mean the same thing. Right, they're interchangeable. We'll see the wording a lot. In calculus, it'll be both. Doesn't matter. Okay. So 3x squared minus 2x plus h, or plus 8. Find the derivative. Or the question could say, find the slope of the tangent line. Okay, either way. Okay, so first of all, I already know from previously when we did this problem, the difference quotient is this, 6x plus 3h minus 2. Okay, I'm not going to go through the steps again of calculating the difference quotient. Whenever you have to find the difference quotient, though, you're going to have to do this whole process again. But we already spent time doing that. I'm not going to do that again. Okay, so I'm kind of fast forwarding here and saying, all right, let's say I did all the work and the difference quotient, I got this. Okay, so now to find the derivative, that means I take the limit as h approaches 0 of 6x plus 3h minus 2. Well, when we're calculating a limit, really the first thing that we do, the first thing that we try is always just to plug in the value. So let's just try to plug in 0 for h. So that would be 6x plus 3 times h is 0, so 6x minus 2. So this is the derivative, 6x minus 2. Now the question could also ask, maybe it doesn't just say find the derivative. It might say find the derivative, let's say, at x equals 4. Okay. So what that means is I'll have to go one step further. So I already have my equation for how to figure it out, which is 6x minus 2. But instead of 6x, I know that x is 4, so 6 times 4 minus 2. So 24 minus 2 is 22. It just depends on what the question asks me. If it just asks for the derivative, then I would end up with an expression like this. But if it asks for the derivative at a specific point, so I first need to find the expression, but then after that, I need to plug in whatever the value is that it tells me. And again, reminder, derivative is the same thing as saying slope of the tangent line. You'll definitely see that on the PFA, is that the wording will say slope of the tangent line. It just means the derivative. Okay, so again, next up, this is something that we did earlier in the year in math analysis. So we found for the function 3 over x, the difference quotient is this thing right here. All right, this one took a little more. We had to get a common denominator so we could combine these things together and then cancel and things like that. A little bit more involved. So let's say same function, but find the derivative. Okay. Well, if I go through all of those steps, which you will have to do, I know that the difference quotient is negative 3 over x times x plus h. So to find the derivative, that means I just take the limit as h approaches 0. So as the distance between those 2 points becomes 0. So what do? Let's just try to plug in 0 for h. So that would be negative 3. X plus 0 is just x. So x times x, x squared. So if it just asks for the derivative, or if it just, then this would be my answer. But maybe it says find the derivative at x equals 6, let's say. Okay. So to find the derivative at x equals 6, I'll just take this expression, which we had from the previous step, negative 3 over x squared, but instead of x, I'm plugging in 6. So negative 3 over 36, which would be negative 1/12. And for these, whenever I say find the derivative at x equals 6, or on this problem when I said find it at x equals 4, I'm just making up those numbers just for what the question could ask you for. There's no specific reason why I chose at x equals 4 or at x equals 6. I'm just throwing out examples for what you could be asked. Okay, so the derivative part, not so bad. Relatively easy. The hard part of this is what you've learned before, is just making sure you get the difference quotient correct. All right, going through all those steps. So you might need to refresh and look back at those, at your notes from that. Right. Or study through, I sent you this file, so you can look at that as well. All right, let's do one more. So this was another, again, this is another example that we did in class together. For this function, we found that the difference quotient is this thing. Or wait, sorry, this thing. Okay, so my first step would be to find the difference quotient, which in this case we already know is this. However, when you do these, you'll have to actually calculate yourself what the difference quotient is. Okay, so now actually to find the derivative, we take the limit as h approaches 0 of the difference quotient. All right, so the only h here is right here, plus 4h, so that's plus 4 times 0, so this just becomes 4x plus 1 times 4x plus 1. Or another way of writing that, 4x plus 1 squared. It's kind of a weird 0. Okay, so there's the derivative. But let's say we want to know, find the derivative at x equals negative 2. Okay, again, I just came up with this randomly. There's no particular reason I chose negative 2, other than it just might be what a question asks you. So find the derivative at x equals negative 2. So I'll just look to what my derivative is, and then I'll plug in negative 2. So negative 20 over 4 times negative 2 plus 1 squared. 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. Negative and negative cancel, so 20/7. It's pretty easy. So again, the hard part is just, do you remember how to do difference quotient, and can you do it without messing up? Like, because look, this This part didn't take much work at all. But in order to get this part, we had to do all of this. Okay, so it's the buildup that takes the most work. The actual derivative part, where you do the limit as h approaches 0, that's not bad at all. Or just plugging in some x value that it wants you to find the derivative at, also not bad. Okay, but just can you do the algebra working up to it? I spit salsa on my laptop. Good idea. It's innovative.